Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 5 of JEE Advanced Physics paper 2017. So let us solve question number 5. Students, let us solve the next question, which is question number 5. It says a circular insulated copper wire, the copper wire is insulated, loop is twisted to form two loops as shown, of area A and 2A. This one is bigger and this one is smaller, having area A and 2A are shown in figure. And this is insulated. At the point of crossing the wires here, remain electrically insulated from each other. So there is no actually conduction taking place between the two loops. It is insulated. The entire loop lies in the plane of the paper like this. A uniform magnetic field B points into the plane of the paper, That means if this is X, this is Y, then this will be positive Z. So that means the magnetic field is pointing into negative Z axis. At time t equals to 0, the loop starts rotating about common diameter. This is the diameter, this is also the diameter, and this is the common diameter. This rotates about this. This loop starts rotating about this at t equals to 0 with a constant angular velocity omega. So this is how it rotates with this axis with omega, angular velocity omega in the magnetic field. Which of the following options is or are correct? So you have to check all options and see which option is correct. First of all, because of the loop, as you can see, this is smaller and this one is bigger, but it is not connected. It goes like that. It is bigger one. So the current goes like that and comes like this. In whatever way the current goes, suppose the current goes like this, in this part it will be like that. So in one loop it is clockwise, then in another loop it will be anti-clockwise. You can have this as anti-clockwise and this as clockwise. So basic concept is that there is no conducting point between the two. It is insulated here. So one loop is clockwise, another loop will be anti-clockwise current. So the flux will be, in one loop the flux is positive and in another loop the flux is negative. So that is our choice, whichever one you take. Suppose that if I want to find for this first loop which area is A and this loop which area is 2A, and the magnetic field is pointing into the plane that is with B, I'll write the flux 1 in the first loop will be minus B A cos omega T. Minus BA cos omega T. I can consider this as anti-clockwise and this as clockwise. If it is area vector is like that, B is that way, then flux is negative. Dot product is negative. So it is negative. Then what is the EMF induced? Because the EMF induced in the loop is proportional to the sum of the area of the two loops. This is also asked. So you have to find the EMF induced in the loops so that you can check this. So let us find that EMF induced is minus d phi 1 by dt for this case. So minus differentiation of this is minus of d by dt of minus BA cos omega t. This comes out to be this minus minus plus, and cos derivative is minus, so it will be minus BA omega sin omega t. This is how is the expression for epsilon 1. So epsilon 1 is minus BA omega sin omega t. I can find the EMF is proportional to the sum of the EMF induced in the loop is proportional to sum of the area. So it talks about the total EMF induced. So let us find the expression for total EMF induced. To find that, we have to think of total area. So what about phi 2? Phi 2 will be 2BA cos omega t. So then E2 is minus d phi 2 by dt. This comes out to be, this is minus minus plus, because the differentiation of cos is negative, so negative, and this is negative plus positive, 2BA omega sin omega t. So what is your phi net? Net flux is 2BA cos omega t, that is net flux is phi 2 plus phi 1, which is this, and that is minus BA cos omega t. So this comes out to be BA cos omega t. This is the net flux. So if I know the net flux, then I can find the net EMF, which is minus d phi net over dt, which comes out to be differentiation of this, and this is negative negative positive. So this will become BA omega sin omega t. So I'm getting net EMF is this, and I can check few options. The options are the amplitude of the maximum induced EMF. This option I can check first. The amplitude of maximum net induced EMF. The amplitude of the maximum net, this one is this one, that is BA omega. Maximum value is BA omega, and the amplitude of maximum net induced EMF due to both the loops, that means net is equal to amplitude of maximum EMF induced in a smaller loop alone. What about the smaller loop? You can see that here the smaller loop, the magnitude is BA omega, and net is also BA omega. So in terms of magnitude, because this is negative, I'll write that E net magnitude is same as E1. So this part is correct, that the maximum amplitude of this, and that equals to BA omega. So in both the cases we have BA omega, but in case of E2 it is not BA omega, it is 2BA omega. So therefore this matches with this, so therefore this option number 2 is correct. Again, we have to see other options as well. We have to find other options, like I will just use another paper. About the sum of the areas, it talks about the first option. You see that is proportional to sum of the areas of the two loops. The induced EMF in the loop is proportional to the net induced EMF in the loop is this one, and that induced EMF. What about the net area? A net equals to A2 minus A1 net, or A1 minus A2, whichever is greater. A2 minus A1 or A1 minus A2, whichever you think as A1 and A2. So this is the difference, and So the EMF induced in the loop is proportional to the sum of the areas of two loops. So here it is not the sum of the two areas, here it is the difference of the two areas of the loops. So E is that E is proportional to A net. E net is proportional to A net, which is proportional to A2 minus A1 or A1 minus A2, whatever it is, you can like that way. So it is the difference, it is not it is a difference, it is the difference, not the sum. It is not the sum, so it is not the sum, this is not right. The net induced EMF due to both the loops is perpendicular to cos omega t, is proportional to. So net induced EMF is proportional to cos omega t. But what we got net induced EMF? Here we got net induced EMF is this expression, and this expression is proportional to sine omega t. So from here I'll write that E net is proportional to sine of omega t. It is not proportional to cos of omega t. So in the question is given that E net is proportional to cos omega t, which is not right because it is proportional to sine omega t. So this is also not right. The last one, the rate of change of flux is maximum when the plane of the loop is perpendicular to the plane of paper. Rate of change of flux is maximum. So when is the rate of change of flux becoming maximum? So to do that, flux we have got BA omega, BA flux we have got BA. What is the flux we are getting? BA cos omega t. Net flux I have got this BA cos omega t. So it talks about the rate of change of flux, that means d phi over dt. Obviously I am talking about the net flux is minus of BA omega and sine omega t. This is how you write the differentiation, and for this to be maximum, it says that this is maximum. It says that the rate of change of flux is maximum. This is the rate of change of flux. It is maximum when the plane of the loop is perpendicular to plane of paper. Plane of loop is perpendicular to plane of paper. So this is the plane of paper, and plane of loop is perpendicular to this. That means these two are having an angle of 90 degree. Okay, whether it is true or false, whether that B and that two things will be perpendicular, B and A is perpendicular, then it will be maximum, because the loop is like this. Then if the loop is like this, the area vector is this way, and magnetic field is like this or this way, so it is perpendicular. So let us check that. To have suppose this is I call this as y. This function y equals to this is maximum when its first derivative is 0. So I'll write the derivative of this, that is y dash, which is equal to d square phi over dt square. This should be equals to minus ba omega square cos omega t. For maxima or minima, this should be 0. So for maximum, y dash should be 0, implies this is 0, that means cos omega t, it should be 0, and therefore this theta, this omega t is theta, this cos theta should be 0, so theta should be 90 degrees. So that means if theta is 90 degree, cos 90 is 0, so that means that the angle between b vector and a vector should be 90 degree. So therefore the option that is given is correct, that fourth option is correct. So rate of change of flux is maximum when the loop is perpendicular to the plane of the paper. If the plane of the paper is like this, the loop should not be parallel to this, the loop should be placed like this. In that case, the rate of change of flux is maximum. So these are the two answers. Thank you.